Alright, so a year ago, I made a video showing how to make a flashlight. Um, Obviously, it was, I didn't explain a lot of things well. So now I'm going to remake it again for like the third time. So first, we're going to go to lighting and we're going to set our technology to future. And we're going to set our time of day to something to where you're actually going to be able to see the light in action. So we're going to come here to start player scripts or character scripts. Character scripts is when the character is first created, while player scripts is when the player is first created. Local script, call this whatever you want. I'm just going to call this flashlight. And we're going to do this using no modules. Obviously, I'm going to show towards the end of the video another way of doing it with a module. But this part will be completely default in Roblox and everything. So you're going to start with local ts equals, this is going to be our tween service, so just local tween service equals game :get service tween service, and then local art, this is going to be our tween info, so we're going to do local tween info, or just tween I because you can't put info because that's the actual API listing for it. Tween equals tween info.new. So first argument is going to be our time. This is going to be how this basically kind of the smoothness. So we're going to do 0.1, and then we're going to do enum.easingstyle. So sign here is my personal favorite, it's the smoothest, and enum.easingDirection. This determines the where the easing style is applied to inside of our graph. This would be a linear easing style. It's a straight line and there's no easing. This would be a sine easing style. Obviously, you typically want to leave this as in out, but if you have this set to in and out, this can be just left blank. Roblox will default it to whatever they think is right. And if we go here, this is where we're going to make another variable here. Local run service equals game :get service run service. And then we're going to come down here to local UIS equals game :get service user input service. And then we're going to set another variable here for local keybind equals enum.keycode.f or whatever you want. And what I like to do is to make this compatible with both PC and console is I like to make the keybind a table. So I do local keybind equals squiggly brackets and then enter. And then inside of this field we put PC equals enum.keycode.f, and then we semicolon or comma, and then do console equals enum.keycode.button.x or whatever on like an Xbox controller. So just for proof of concept, we're just going to do button X because I'm pretty sure that's unused. And then we're going to come down here to run service dot render stepped connect function dt for delta time. So I'm actually just going to make this delta time just so that it's a little bit easier to read. And here, this is where we're going to basically set the position of the flashlight and everything. So now we need to come back up here. We need to set up our part that will have the light inside of it. So we're going to do local part equals instance.new part, and then part.name equals just one equal, not two, equals flashlight, and then part.anchored equals true, part.canCollide equals false, part.canQuery equals false, and part.canTouch equals false. CanCollide is so that you won't go flying away if you're in first person. This will prevent the part from touching anything else. CanQuery will prevent raycast from affecting the part, and CanTouch will prevent any touch functions in say a global touch system that detects a part's name or whatever, this would prevent it from detecting that if it touches the player. And now we're going to come down here to part.size equals vector3.new, and then this is going to be the size in studs. So we're going to do 0.1, 0.1, 0.1. This will make it relatively small while keeping it, visible somewhat for debugging. And then we're going to set an offset. So we're going to do local offset equals cframe.new 0, 0, 0. This will be the offset in a C-frame, still in studs, of the distance that this part will be sitting from the camera. So if we want it more in front of the camera, we would set the Z to -1. If we want this behind the camera more to prevent it from clipping, we can do just +1. And you can do, decimal points and everything if you need it more fine-tuned. You can also move it to the left with X and up and down with Y. Now we're going to create our spotlight. So we're going to do local spotlight equals instance.new spotlight. And I almost forgot, come back up here to part and go ahead and set part.parent equals, and real quickly, let's set a variable for our camera. So local camera equals workspace.current camera. We're going to set the parent of this part to camera. And now we're going to come back down here to our spotlight. Spotlight.name equals light. Let's spell that, light. Spotlight.parent equals part. Spotlight.range equals 60. Spotlight.brightness equals 1. Spotlight.shadows equals true. So what this will do is this will create our spotlight via the instance API, creating a new spotlight class, and then we're going to be parenting that to our part and naming it to light, and then we're going to be setting its range to 60 studs, the brightness to 1, and the shadows, this will create shadows if it hits a prop or a part or anything, or a character, or just kind of any physical object in the world. This will make it have, shadows on it. And then we're going to come down here and we're going to set part.cframe equals camera.cframe. And real quickly, so that we make sure that it's facing the right direction, spotlight.face equals enum.normal_id.front. So this will make sure that the spotlight is facing out front of the part that we created, which would be where it's looking. This will create a light at the camera, as you can see. And you can adjust its brightness. If you go here and go to spotlight.brightness, you can change it to 5. And this will make it a little bit too bright, honestly, because then it starts making everything glow. But this may be good if your game is super dark and you really need to be able to see what you're doing. And next we're going to go back into our script. This is where we're going to add our smoothing to our light. So we're going to go ahead and remove this part.cframe equals camera.cframe, and we're going to set our variables for our tween. So we're going to do local tween equals tween service :create. And this is the instance argument is going to be the part that creates the light. And then we're going to have our tween info. This is what we set up here. Our the smooth time, or the time it takes for the tween to finish, and our smoothing type, or aka just easing style. And then our property table. This is where we're going to set our variable for what it's supposed to do. So cframe equals camera.cframe. And now we can do tween :play. And this will then make it to where it smoothly moves to where the camera is. The only problem with this is whenever you walk, it is delayed behind you. If you want that, you can keep it, but you're gonna set the parts transparency here to 1. So part.transparency equals 1. This is so that it's invisible. 1 is invisible, 0 is visible. Anywhere in between is partial. So to lock our position we're actually not going to change the overall C-frame. We're just going to set the part C-frame up here, camera.cframe. So part.cframe equals camera.cframe while keeping our tween down here. But instead of setting our C-frame directly to this, what we're going to do is we're going to do camera.cframe, copy this, C-frame equals C-frame.lookAt, and then this is where we're going to have the part, so camera.cframe, or just part.cframe, and then this is what it's going to look at. This will be the look vector of our camera, so camera.cframe.lookVector. So now this will look in the direction of which the camera's looking. And I almost forgot right here, part.cframe, make sure that this is part.cframe.position. Alright, so I messed up a little bit, sorry. So whenever you do part.cframe equals camera.cframe, make sure to do part.position equals camera.cframe.position. This will make it to where it only sets the position of the part and not the rotation, so that down here we will actually set its rotation. That'll be smooth. And then after you do all this, make sure that when you go to your tween, and then just do camera.cframe.lookVector times 360. So let's go ahead and have an overview of this. So we create our tween service. This will get the service of tween service. And then we create our tween info, which will give us our smoothing time, the quickness of our tween. And then the easing style, this is the way that it'll move. The run service, this will allow us to have render steps. So every time the game renders a frame, this will play. User input service, this will be used for toggling, which I'll get to in a minute. Our camera, which is our workspace.current camera. Our part, which this creates our part that will actually hold our spotlight, and this will be what's actually smoothly moved to the camera's position. Then we have our spotlight. This is what produces the light, obviously. This will be inside of our part, looking out the front normal. And then here we have our offset. You come down here to add the offset. You can come down here to part.position equals cameras.cframe.position. Alright, so I went ahead and rewrote this part right here. So do part.position equals, in parentheses, opening bracket, camera.cframe times offset, closing bracket, dot position. And this will then allow you to have an offset on your part inside of your camera. As you can see, it's now in front of our camera based on that offset that we give. So that's 3 studs in front of our camera. And we're just going to set this back to 0. Because we don't need the offset right now. Our keybinds here, PC equals your keyboard's keybind, which would be F for flashlight, and console would be the key code for button X, i.e. X on the controller, or A, or B, or Y, or the PlayStation variants. This is emulated over to the PlayStation version. And then we have our render step here, which obviously it runs every frame. And we set our part's position to camera.cframe times offset dot position. This times offset will give us our offset in the directions that we gave up here based on the camera's C-frame. And then we get the position so that we can set the part's position. That way it'll lock every other C-frame variable that it has. And then down here we have our tween. We create our tween. And we have our C-frame set to cframe.lookAt, part.cframe.position. This is the position that it'll start at. And then we have our look vector of our camera, and this is where it'll look at. So you could set this to mouse.hit.p or mouse.hit.position so that you can have it look at the mouse, but then that won't work on mobile. So then you have to make sure that if it's on mobile, check if it's on mobile, which you should be able to find something like that on the dev forum. I'm not 100% sure on how to do it, so I can't really show it right now. That should be, and then we play our tween. This is not the most performant way of doing this. Let me show you the more performant way of actually handling this. So what we would do is we would take we're going to save our cframe.lookAt here. We're going to copy this, put it up here, and comment it out right here. So we have this saved and backed up. And we're going to remove this, and we're going to do part.cframe equals part.cframe : lerp. And then our goal is our cframe.lookAt. and our alpha is the smoothness, or the time it takes, or is the smoothness. So 1 is instant, 0.1 is slow, and so we're gonna have this at like 0, let's say 0.6. That should be a good amount. And now if we play, it'll smoothly, you know, snap while locking the position to our head, and at the same time smoothly rotating. So to show this even more, let me just set this to like 0.1. And now you can really see. I mean, it will wrap around, but of course, no matter what you do, that's going to happen with, you know, smooth flashlights and whatnot. But to prevent that, just set this to a higher number, like 0.4 or 0.6 for proof of concept. And that'll prevent it from, you know, doing a full 180, as you can see. All right, so this is future me. This is this is at the end of the script here. I had a revelation right before finishing this video and closing studio and everything, that you can actually just, I realized that you can just, instead of doing look at here, just literally just set it to where it sets it directly to the camera C frame. Because if we're setting the position here, that's only setting the position and not the rotation and everything. So you don't actually need to do all that extra stuff for the, you don't need to do the C-frame.lookAt for just setting its rotation. You can literally just set its C-frame to the camera C-frame. So if that helped, you know, simplify things, here you go. So yeah, let me just get back to where I was earlier in the video. And that is a client-sided way of making this. If you want to make this server-sided, what you would do is you come to replicated storage, create a remote event, and set this to flashlight mirror, and then make a server script service script. This we'll just call this flashlight server, and we'll create a couple variables here, like local rep s for replicated storage equals game :get service replicated storage, and then local mirror equals rep s dot flashlight mirror. And then now, instead of creating our flashlight part based on the player, this will only be visible to the player. So we're going to try to keep this smooth, quote unquote, as possible. So we're going to actually name this part flashlight underscore client, so that we can, you know, differentiate between the two. So what we're going to do inside of our server script now is do local players equals game :get service players dot player added connect function player, and this will make it to whenever a player joins, this will, you know, do what it needs to do. And we're going to put our spotlight and part instancing inside of here. And then we're going to set our part.parent to player.character. And a way that we can prevent this from erroring whenever you reset is just do player.character or character added connect function character, or you can do local character equals player.character or player.character added wait. Then now we can run this here and add it to our character. And then we can go ahead and change our name here from flashlight underscore client to flashlight underscore server. And then here, inside of our client-sided script, in render steps, we're going to set camera dot flashlight server dot light dot brighten dot enabled equals false. And to prevent this from erroring, we're going to do if camera : find first child flashlight server, then run that part, then run camera.flashlightServer.light.enabled equals false. This will make it to where it'll, keep it that it's not double light. It'll only, portray the light on one side of the server, on the server side and not your client. Now we're going to go back to flashlight server. We're going to come down here and do mirror.onServerEvent connect function. And we're going to have a few variables here. Player, origin, and direction. And now we have our function here. And here, this will be our kind of, you could say, delayed, our delayed function here. So our way of kind of keeping this performant is come back to our flashlight. Above here, we're going to do local last tick equals tick. And then here, inside of run service render stepped, we're going to do if in parentheses tick, if tick minus last tick is greater or equal to 0 point, and this is going to be our time delay. So we're going to do, let's say every 1 second we want this to update. Then last tick equals tick, so that this way this will keep cycling. And then we're going to, real quickly, we're going to grab our mirror and replicated storage variables and put them up here. So that way we have these saved here as well, just for easier access. And then run our mirror fire server and our position, which will be camera.cframe. And then our direction, which will be camera, which we can just, do camera.cframe.lookVector times 360. And now we're going to go to flashlight server, and just to prove that it'll, keep a delay, we're going to do print fired and play test real quick. So now it's every second it'll update our flashlight. Obviously right now nothing is showing. Okay, nothing is showing. Alright, so as we have this right now, this will not work if the player resets. So to fix that, we're going to remove this part and do player.characterAdded connect function character, and then put this inside of there. And now whenever you reset, as you can see inside of the player, it's there. And now whenever you reset, it will recreate that inside of your character. So that way it'll prevent it from, despawning every time you die and respawn. So that way you can, add dying into your game and, keep the flashlight there. And down here, we're going to check the player. We're going to make sure that we have the character. So we're going to do local char equals player.character or player.character added wait. And then we're going to update the parts look at to what we're going to do. So we're not going to lerp it this time, because the lerping that's for the client to make it smooth. We're not going to have the smooth for the server side, which would be for all the other players. This is just for performance because, so we're not going to add smoothing because on the server side, it's just not necessary for other players to see. It's not going to be visually any different for other players, because if this is going to be updated at a very low rate, there's no need for it to be smooth. So actually, instead of every 1 second, we're just going to set this to like every let's say quarter of a second. So it's still going to be somewhat fast while keeping it low. So this number right here is the amount of delay. So this will be kind of your wanted update rate for server. So the lower this number, or the faster it's going to be on the server for everyone else to see. But the higher this number, the slower everyone else is going to see your flashlight update. So if you were to move, the flashlight would stay where it is until this update rate is reached. So we're just going to keep this low, like every 0.05. So that's relatively, that's pretty fast for what we're doing. and we're going to come back to our server, and this is where we're going to set the C-frame. So we don't actually need our direction because we're not lerping. And now we can do char dot flat colon, or first we're going to check if there's even a flashlight in there. So if char colon find first child, and we're going to copy the name up here, then flashlight, or if find first child flashlight server, then char dot flashlight server dot C-frame equals origin, which will be our C-frame. And now, as we can see, it's updating. And as you can see, it is slightly delayed for the sake of performance. And now, as we can see, for the client, it's enabled. But the way we can fix that is to come inside of flashlight. And the problem is we're checking the camera, not the character. So to check the character, we're going to do local player equals game.players.localPlayer. Local character equals player.character, or player.character added connect, or just colon wait, not connect, just wait. And down here we're going to do char find first and char.flashlight server. So that way it's checking the character and not the camera, because there's no flashlight server inside the camera, because you can't do that via the server. Now we're going to play and test, and as you can see, there's only one light. But if we were to start this in a 2-player test, and as you can see now that I started it in a 2-player test, we can see that these are now replicated between the 2 players. So let's get our other player open here. So as we can see, it's being updated to the player. So if we're in first person and we look this way and have this one open at the same time, let's go ahead and just kind of pin this here, close our Explorer so that we can actually see. As we can see, as I move, it's updated. And as you can see, it's where we're looking. But the problem is, for the server, is it is clipping with our head, and it's, seeing through the head and everything. And we don't want that. We don't want that because it'll cause, issues of, if a player is looking down like, oh, look at this, man. You can't see it. So let's click clean up and come back to our server, and let's add a slight offset to the origin. So we're going to do times cframe.new, and this will kind of be our offset like we did in the client offset. And we're going to, in a way that we can add this offset here, is we can actually just come back over here, and instead of doing this, we can just yoink this right here and put it into here. So we're going to have camera.cframe times offset, so that our offset will be saved here. If you, in theory, wanted to have different offsets for each, for the client and the server, you can do local offset server, and this will have a separate offset for the server side. So the main side will have a client, and the server side will have a server side offset. And here we're going to add our offset of -1, so that way you don't get that, through the head shadowing and everything, and the other players can see what you're looking at properly. And here, as we can see, it's now updating properly. And now that there's an offset, if the character would stop, moving around so much, you can see now that the light, you can look around, you can actually see everything. So I'm accidentally messed up the offset here. Alright, so I went ahead and fixed it. So all you had to do was set the offset on the Z. So if we come back here to our script here, set it to -2 on the server-sided one, and that'll fix your issue with it showing there. But now that brings up another problem that a lot of people probably don't want, is that if there is a part in front of the player, if they're in first person, this light will then phase through the wall. So obviously, if this is going to be used for, horror games or something like that, where there's no PvP involved, that's 100% fine. There's not going to be a problem there. But if this is going to be used in any kind of PvP situation, then you probably aren't going to want that happening. So there's probably going to be another solution for that. I'm not going to go into depth on that. It would just take too long to explain. But obviously, as you can see, it works. You can see it's depending on where the player looks. The flashlight moves on the server as well. And it's based on an update rate, so it's more performant. And it's not doubled on the client. So there's not 2 lights going off at once. As always, thank you guys so much for watching. I'm actually going to leave this as a model in the description. Everything will be 100% listed where you're supposed to put everything, so that it's completely easily understandable. Everything should be 100% as is in the video, except for the fact that here I'll go ahead and add. I'll probably add some comments to explain, everything. So the tween version I'm gonna leave out of the model due to the fact that it's just not the best version. It honestly kind of sucks. So I'm just gonna leave the lerp version. It's smooth. It's pretty much, what you'd expect. Other than that, everything in these scripts should be completely one-to-one in the videos, or in the video and on the model. No, I'm not going to change any part of these at all. Everything here is going to be 100% one-to-one. Thank you so much for spending your time watching this video, and hopefully you learned something from this. I know I'm not the best at explaining things, but hopefully you could understand the basic premise of some of these functions and what they do and how this script actually works.